we need a vector 3 surface, or normal, I should say, and a float, which is the grid size. And then quaternion, surface rotation, vector up to the normal, okay. And we'll say this is the local position, which is what dot inverse times the position, local position equals snap to grid, return surface rotation times local position. Okay. All right. Update. Now we're going to use, instead of snap to grid, we're going to use snap to surface grid. We have to pass in the hit normal as well. Now, I'll be honest, I'm looking at this from an AI prompt that was helpful, and I don't understand this. So we're going to ask Copilot what the explain this function to me. I want to understand what this is doing. Let's break it down. It's designed to snap a given position to a grid that is aligned with a surface defined by its normal vector. This is using in scenarios like placing objects on uneven surfaces in the game, ensuring they align properly with the surface grid. Okay. So we're obviously passing in the position, we're passing in the normal of the surface that we're hitting, and the grid size. This line creates a rotation that aligns the vector up direction, which points upward, with the provided normal vector of the surface. This rotation helps in transforming the position to local space of the surface. So I guess like if you're a wall, yeah, you do have to pay for Copilot. It's an annual fee of, I think, like $80 or something, or $100. So I use it for work. So I am trying to get my work to pay for it, but because I use it for work, I justify it as like an expense. So, but it's an annual fee. So, all right. So if it's the wall or the floor, so we're getting a quaternion that represents the orientation of the normal in relation to up. This is the part that I don't understand. So, okay, so I get this. So we got like some sort of rotation going on. We know the orientation that the object should be relative to the surface that I'm hitting. So if the surface is on a slant, or it's like this, or it's like upside down. But this part I don't understand. Position is transformed into local space of the surface by applying the inverse of the surface rotation This makes it easier to snap the position to the grid relative to the surface. Okay. So it's okay. So this is transforming into local space, I guess. And then we're calling snap to grid, which does that grid size rounding. And then we transform it back to rotate. So we're going to local space. We're adjusting the position slightly to make sure it snaps to a grid. And then we're turning it back into world space. I guess that's what it's doing. And it says gotchas. Grid size can be chosen appropriately based on the scale of your game objects and the desired precision. Okay. All right. Copilot's very good. It integrates right into VS Code, and it integrates into VS Studio, obviously. So it's still okay. So this looks good. Snapping relatively to the angle that I want. See, like it rotated that because that surface is angled. This surface is towards me. It's using the collider, so it may not line up with the geometry exactly, but it's doing what I want. Okay, so I think that is okay. Now I still need to get this to sit on top. So if we go back to here, it's this piece of code that's making stuff flicker. If I place this back, this should actually be position. So in this example that it generated, it's actually keeping a local version of the preview. No, but it's using the reference. Preview collider, although it calculates the bounds. What does it use the collider for? Doesn't actually use the collider for anything. Just make sure that it has it. Okay. So maybe that's what's causing the problem. Is I was using the bounds of the collider, but that's actually not what it's doing here. So let's mimic this a little bit. So we need a reference to some bounds. So private bounds. And then when I spawn the placer object, we're going to call bounds equals calculate bounds. And we're going to create this function. Oops. Okay. So calculate bounds. So we say bounds equals new bounds bool first true for each renderer in we're going to get the renderers. So actually we can pre-cache this here. We actually do have that already. So we can return that. So we don't have to fetch it here. We can say renderers. And we can say if first, then the bounds equals that. Otherwise, we encapsulate. And then we return the bounds. Okay. So now my bounds is set here. And then what they do is they pre-calculate some values. So they have a vector 3 called bounds center and bounds extents. So after we calculate our bounds from our preview object, we say bounds center equals the bounds dot center minus the dot transform dot position, and then they do the extents as this. Okay. Then in this function that I was working on, which is this, instead of this, they say bounds center, and then they say equals the negative of the bounds extents dot y. And then the position equals the bottom center. Then we check if grid snapping is enabled. And then if it is, we do the snap to the surface using the position, the hit normal, and the grid size, and we return the position. So this is how they did it. And let's see if AI is smarter than me. Are you ready? Who's ready? Who's ready to see if it's worth all the money and all the hype? Holy shit. I mean, this is obviously collision, but oh, it's working on the floor, but not on the wall. And my guess it's because I'm using the Y coordinate. I'm sure if I modified it a little bit to take into consideration that it's being pushed on a wall. But look, it's like even detecting the ceiling and doing the angle thing. Oh, I broke it. Okay, so it's not perfect, but it is doing... It's doing what I wanted. And then if I hit G, snapping the grid. Look at that. I should quit. I should quit my job and let AI take over. I don't know how good I feel about it. All right. So let's go back to this solution real quick and just make sure. They did have another way of detecting valid placement, which we want as well. So which was in the check placeable. We're calling is valid placement. And we're passing this, but we also need to pass, because the position is being changed, we're gonna have to pass the position here because it's no longer the hit. So vector 3 position. We're gonna have to add this as well. And we're going to pass position here. And then can place, which means we're going to have to update this to vector 3 position. We have to pass the position here as well. And then we're gonna have to go to construction kit. We have to add that. Okay. So we're checking if the layer is good. We're checking if the surface is valid. We're now gonna have to make sure that let's just copy this function in and try to understand it. So we have is layer is valid, surface is valid, and then we're going to have placement is valid. If placement is valid. And we're going to need the position and the normal. And we're going to make this say not false. And I spelled that wrong. And then let's create this. Oh, not the extract method. I don't know why it defaults to that first. Excuse me. Turn false. Okay, we're going to do a vector 3. Box center position plus So we're going to need the center of the bounds. This is our calculated bounds because this is actually in their version. This is in the other thing. So for now, because we're adjusting the positions, I think it's okay to use the collider. Because we're in the construction kit, right? Oh, this is the blueprint. So we need the blue. Wait, what? Preview object. Preview object. Dot collider dot setter. Quaternion. Rotation. Preview object. Transform, not rotation. Float up. Up. Oh my goodness, I cannot type. Offset. And then vector 3, start position, box center. Vector 3 up times the offset. If physics dot boxcast start position. Start position. Down. Out. Raycast hit, rotation, up, offset, plus 0.1 F, place. Okay. Oh, valid layers we'll use. Valid layers. Valid layers. Okay. Bounds start position. Bounds extents. Vector 3. It's not extends, it's extents. Okay. And float surface angle equals vector 3 angle between the hit normal and the normal, and then return surface angle less than 5. And let's actually make that configurable. Set field private float minimum surface angle minimum. Okay. Sorry if I'm missing chat here. Taper, welcome, welcome. Sorry, I'm sorting this all out. So actually we can turn this into if this and this and this return true, else return false. You know what? I like it the other way. It's a little bit more verbose, but you can see so now this should make sure that it doesn't collide with anything. The only trick is that it's only doing down. And I realized the actual, I'm using this box. What I really should be using is the actual treasure chest. So props. Unpack completely. Move. Just basically remove everything. Move. So let's point. Okay. 0.6. Too high. 5. 0.325. Okay. Okay. And then prefabs, materials.